Let's start with our fifth problem, number 53, maximum subarray. The goal here is to find the subarray with the largest sum. So let's see what is a subarray. A subarray needs to be a part of the array which is continuous, right? So this can be a subarray, but you cannot take -3 and then 2 and then 4. That isn't a subarray. It needs to be continuous. So let's see how to approach this. There's a algorithm that we use for this called the Kadane's algorithm. Let's see how that works. We'll have a current sum and a max sum, right? Both of them will be initialized to the first number in the array, and then on moving forward we'll update the current sum and the max sum. So what are we doing? We are checking if the current number is bigger or the current number and the current sum is bigger. For example, if we take 1 and -3, which is -2, right? And then we have 4. So there's no point in adding -2 to 4. It will give you a 2. We can just ignore this part and start with the current number. So we are checking the max between the current number and the current number plus the current sum. We'll define the max sum and the current sum as the first value in the array and then start with our iterations. So on the first iteration we have current sum is max of current number, which is 1, or current number plus current sum. Is the sum making sense here? So 1 plus -2 is -1. So 1 is bigger. We'll update the current sum as 1, and max sum is max of current sum or the max sum, which was -2. So now it is updated as 1. So we'll move to the next iteration, which is -3 greater or -3 plus 1 greater, which is the current sum here. So -2 is greater. So we'll update the current sum as -2, and the max sum is still 1 because -2 is lesser than 1. So we'll move to the third iteration, which is 4. So is 4 greater or 4 plus current sum, which is -2, greater? So 4 is greater. We update the current sum as 4 and the max sum as 4 as well. We'll move to the next iteration, where is -1 greater or -1 plus the current sum, which is 4, 3 greater. So the current sum will be 3, but the maximum is still 4. Let's move to the next iteration. We'll check if 2 is greater or 2 plus the current sum, which is 3. So 2 plus 3 is 5. So 5 is greater. So we'll update the current sum and also the max sum in this case. We'll move to the next iteration, which is 1 greater or 1 plus the current sum, which is 5 greater. So 6 is greater. We'll update it at 6 and max sum as 6. I'll move again. So is -5 bigger or -5 plus the current sum, which is 6? So 1 is bigger. We'll update the current sum as 1, but the max sum stays at 6. We move it to 4 now. Is 4 bigger or 4 plus the current sum, which is 1, which is 5? 5 is bigger. So we update the current sum as 5, but the maximum sum stays at 6, which is also the answer of this question. So let's write some code. We'll define the max sum and the current sum as nums of 0, then start the loop with the first index. We'll update the current sum. Is the current number bigger or the cumulative addition of the current sum plus the current number? We are checking if the current number adding to our cumulative sum makes sense. Update the max sum as well, which is math.max of current sum and max sum, and we return max sum. Let's run this. There's a small mistake here. Let's run this. Great. Accepted. Let's submit it. Perfect.